with the triangle inequality. What it does is gives us a way of figuring out, what are the possible lengths of the sides of a triangle. If you think about it, you could have a triangle where, okay, you made these two like this and they're this side, but this side wouldn't be long enough to get to the other side, right? Or if you were able to get to that one, this side might be too long as well, okay? Not every, you can't just pick three numbers and say that's the length of the sides of a triangle. There's a possibility that it wouldn't be possible, okay? And the triangle inequality theorem is what defines what's possible. Okay, first things first. And I've got them color coordinated like the book here to help you. For instance, AB plus AC has to be bigger than BC. So I'm saying the orange one here, AB plus the green one, AC, and those added together has to be bigger than BC. Now why did I pick those two sides? Well, there are three inequalities here. So it didn't matter where I started. There's three possible combinations of this theorem. The other possible combination is the orange plus the what? Purple has got to be bigger than what? The green. Or AB plus BC is greater than what? AC. Now, and then the third one, green plus purple has to be bigger than orange. These two lengths added together must be bigger than that. If it's not, then that can't be the lengths of the sides of a triangle. Okay? The sum of two sides of a triangle must be larger than the third side. What do you think I mean there by the third side? Anybody? How many sides are there in a triangle? Okay. I'm saying the sum of two sides of the triangle must be larger than the third side. How many sides of the triangle am I speaking of here? The first two, and then what's left? Only the what? The other or the third side. So that's what I mean, the sum of these two sides must be bigger than the other third side that's left. You call that the third side. Because you already have spoke about the first two, haven't you? That's what that means. Make sure we have that written down. There's not a whole lot to this section. We'll do some examples now, and then we'll have one more kind of rule to write down. We'll expand on this basically just a little bit more. But everything in this section is based off of that fact. What we're going to do next is we'll do some examples. And how about I work these examples out. We'll work them out together, and then you can write them down. Has everybody got that written down to where I can unfreeze it? Anybody? So we're good? Okay, your directions here. Could the given three numbers be the lengths of the sides of a triangle? Well, my first one, let's go with 3, 4, and 5. What I'm saying is, could those be the lengths of the sides of a triangle? There's only one way to find out. You have to see if it fits all three in the inequality. So everyone watching, do this with me. Write it down after we're done. We'll do about 3 of them. First of all, 3 plus 4. What do I have to see? What does that have to be? Greater than what? The third side, which the next side is what? 5. Is 7 greater than 5? True, so we're good. This is also what I expect to see on every problem. This written out, worked out, tell me whether it's true, whether it's false. When you do them like this. Why is that? Because I'm mean? Oh, I'm sure that's some of it. But mostly, and all of it is, that I want you basically writing down the triangle inequality again and again. I want you proving that you understand the concept that the sum of two sides has to be bigger than what? The third side. Triangle inequality is an important thing. I want you proving that you understand it. Well, I did 3 plus 4. How about we do 4 plus 5 now? 4 plus 5, well, what does it have to be bigger than? What is 4 plus 5? Is 9 greater than 3? True, good. Only one left to do. And what is that? 3 plus what? 5. Is it greater than 4? Is 8 greater than 4? True. So, can this be the lengths of the sides of a triangle? Yes, it can. That wasn't too bad, was it? Let's look at this one. First one would be what? 8 plus 10. Is that greater than 1? Is 18 greater than 1? True. 10 plus 1. Is that greater than 8? Is 11 greater than 8? And what's my last one? Is 8 plus 1 greater than 10? Is 9 greater than 10? No, it's not. So this is false. So could this be the lengths of a triangle? No, it could not. Doesn't matter if 2 or 3 of them work. What about here? What's my first one? 9 plus 10, that has to be greater than what? Is 19 greater than 19? No, it's not. You don't even need to go anymore. What is the answer here? No, this cannot be the lengths of a triangle. Not so terrible, is it? And how about 6, 4, and 9? 6 plus 4, is that greater than 9? Is 10 greater than 9? Okay, next one. 4 plus 9, is that greater than 6? Is 13 greater than 6? True. And then 6 plus 9, is that greater than 4? Is 15 greater than 4? So could this be a triangle? Yes, it could. I went ahead and, I'll tell you what, we'll go on to the next one. I went ahead and screen captured it, and I'll post the rest of them on Canvas for you. How about that? And then you can write them down from there. That way we can go on to the next one. The next question I have for you, before I leave room for a statement here in your notes, kind of gone down here, but the first thing is I want to talk about this example. And my question is to you, if the sides of a triangle are 8, 11, and x, what are the possibilities for x? Well, what have we said? It has to be what? It can't be bigger than what? Everyone, like I said, if you want me to, I'll screenshot a picture of this too. Okay? But you can, actually I won't. You can write this down in just a second because it'll be the last thing we do. Everyone look at this. Does anyone have an idea on the possibilities for x? Where, what it might have to be. What do we know? What do we know about the third side?
It has to be less than the other two sides
Combined,
combined.
right. So what do we know about x? We know that x has got to be less than what? 19? So my question to you is that the only thing? Do you think that there are numbers less than 19 that wouldn't work? And if so, tell me one.
1.
Or 0? I mean, could you have a triangle if the third side was 0? No, you just have two lines. They'd move to each other and get, they'd move to each other and get closer, and then boom, they'd connect, wouldn't they? So obviously there's a limit or a, down at the bottom too that's got to be bigger than. Well, how in the world are we going to figure that out? Well, don't write this down, but looking at this picture right here, I'm going to do this with pencil so I can erase it. For instance, right here, this represents a number, does it not? Could I not subtract AB from both sides? And I would end up with AC has got to be greater than BC minus AB. Have I done anything wrong by doing that? So this third side had to be smaller than what? The other two added together, and this side has to be less than those two what? Subtracted. That is where you get the statement I'm going to write down now about the third side. And you need to write this down. The third side of a triangle must always be greater than what? The difference of the other two sides. And less than the what? Sum of the other two sides. So with that in mind, what do you think I could do down here? X has got to be less than 19, but it also has got to be greater than what? Now, do you think, does it make sense to go 8 minus 11 and get a negative 3? Is it possible to have a negative length of a side? What do you think it's always got to be? The positive difference, right? I'm not writing that in my statement, but I would hope we would. I know what they say about assuming things, but are we understood that that makes sense, that obviously has to be the positive one? We okay with that? So what does X have to be greater than? What does this third side have to be greater than? Has to be less than the sum and greater than the? Has to be greater than What's the difference? 11 minus 8 is what? 3. That's kind of, that up there kind of shortened, didn't it? Less than the sum, greater than the what? Difference. Now, well, I will expect you to write your answers as a compound inequality. You guys remember how to do that from algebra? That's when you, basically you've got x in the middle here, right? And usually you put your lower limit on the left, upper on the right. So x has to be greater than what? 3, and less than what? 19. That's how you should write your answer. See how it looks like? It looks like it's between 3 and what? 19, doesn't it? It's less than, the smaller part's pointing at the x here, 19. The bigger part's pointing at the x here, greater than 3. Any questions on that? That makes sense? Any questions at all? All right. Do, at the end of the hour, Wednesday, this is 5.5, by the way. We're skipping 5.4. Numbers 1 through 3. 5 through 14, 21, 23, 26, and 27 through 30. Write the problems, draw the figures, show all steps, and work. I expect to see this stuff up here. You hear me? I'm going to send you back if it's not there. Any questions on any of this? Pretty easy section, right? You have, looks like, great day. You have 25 minutes to work on your assignment. We will not get our stuff ready at 1 minute till. All you should have out is a book that you get to put onto your desk and a piece of paper. You can have your folder out and ready to quick put that in when that chime rings. I want you to use this time wisely, where you can ask questions,